In episode 60, titled Harden Hosts Using HIPS, HIDS, and Host Firewalls, we treat host hardening as layered prevention, detection, and containment that lives directly on the endpoint. The network can help, and the cloud can assist, but the decisive moment often happens on a laptop, a server, or a container node where code tries to execute, files try to change, and credentials try to move. Our goal is to stack sensible controls that stop the easy things outright, see the subtle things quickly, and fail safely when surprises occur. We will ground each choice in plain artifacts, configuration states, block logs, rule hits, and isolation actions, so you can prove not just that a control exists, but that it works under stress without breaking real work. Start with secure baselines, because prevention begins with what the machine is allowed to be. A baseline enumerates services, open ports, scheduled tasks, kernel or driver modules, and the registry or PLIST settings that must exist, and those that must not. Enforce it with a policy engine that can both assert state and report drift, so should becomes measurable. Every deviation produces a small, precise breadcrumb: what changed, when, by whom, or by what process. Tight baselines reduce the attack surface, keep noise out of your detections, and turn configuration review into a diff rather than a scavenger hunt. When auditors or responders ask how you know a host was trustworthy at noon on Tuesday, the baseline and its enforcement trail are your answer. A host-based intrusion prevention system, HIPS, blocks techniques rather than chasing families, which is exactly what you want at the point of execution. Tune it to stop exploit primitives like shellcode injection, stack pivoting, and return-oriented programming patterns that show up in memory behavior before malware has a name. Add guards for untrusted code execution that require signatures, reputation, or explicit allow listing before binaries and scripts can start. Pair those with mitigations that enforce data execution prevention and address space layout randomization policies wherever the platform supports them. Good HIP's posture is visible. You can show exploit blocks with call stacks, memory region details, and the parent process that triggered the event. That evidence keeps conversations focused on facts rather than feelings when someone asks why a tool was stopped. A host-based intrusion detection system, HIDS, complements prevention by watching for the quiet changes that shape persistence and tampering. Configure it to monitor critical files and directories, sensitive registry keys or preference domains, kernel or userland modules, and service definitions. Calibrate alerts to fire on integrity and context, not mere activity. A signed system file that changes during a patch window may be acceptable, while a run key appearing at 2 in the morning from a script host is not. Include protections for configuration stores used by your agents themselves, so an attacker cannot blind the guardrail. The best HIDS deployments generate few but meaningful events, each with enough context, old hash, new hash, process, user, to let an analyst move from alert to decision without a research project. Host firewalls enforce least privilege where it matters, on the device that originates or receives traffic. Define role-specific inbound policies so only the services that truly need to listen are reachable, and then only from the right peers or subnets. For egress, replace any to internet with a shortlist tied to business purpose, update services, package repositories, proxies, and named application endpoints. Stateful inspection keeps replies smooth while shutting down unsolicited reach. And application-aware rules prevent protocol smuggling that tries to ride permitted ports. Logs should make intent legible: source, destination, rule identifier, and reason string. When investigators ask, why could this process talk to that site, you can answer with a single line that doubles as living documentation. Application allow listing and script controls convert principle into practice by narrowing what is allowed to run. Build allow lists from signed, known good binaries, include publisher and path rules where appropriate, and require explicit approvals for unusual tools that engineers legitimately need. Script controls gate engines like PowerShell, Python, and AppleScript so they run with constrained languages, approved modules, and logging turned on, while unknown scripts are blocked or require just-in-time authorization. Exceptions must be visible, time-bound, and owned. Anything else quietly becomes policy by neglect. The artifact you keep is simple: a record that says which executable was allowed, by whom, for how long, and what work it enabled. That transparency keeps the system usable without turning it into a sieve. Credentials are crown jewels on every host, so guard them with platform-native protections first. Enable local security authority protections and credential guard equivalents to isolate secrets from arbitrary process reading. On macOS, harden keychain access policies and require user presence or hardware-backed factors for sensitive items. Disable legacy authentication protocols and cached credential behaviors wherever practical, and push passwordless or phishing-resistant factors for elevation. Watch for handle requests to sensitive processes and for unusual use of credential export utilities. Treat those as immediate containment triggers rather than curiosities. A small investment here pays outsized dividends because so many intrusions accelerate only after an attacker can replay or mint tokens. Patching remains one of the highest yield practices, but reliability determines whether teams stick with it. Automate operating system, application, and firmware updates through staged rings that move from canary to cohort to fleet, and instrument each stage with success rates, rollbacks, and user impact metrics. Pre-approve emergency paths for high-severity issues, but make sure rollback readiness is real, snapshots exist, prior versions are cached, and maintenance windows are respected. Firmware deserves equal attention because many modern defenses live below the operating system. The story you want to tell is unremarkable. Updates happen on time, failures are rare and reversible, and the logs explain exceptions without hand-waving. Endpoint detection and response, EDR, ties the layers together by narrating behavior across processes and time. Turn on process analytics that capture parent-child relationships, command lines, loaded modules, network connections, and file touches. Add behavioral detections for things like process hollowing, script-to-binary pivots, and suspicious token usage. Most importantly, ensure rapid remote isolation is one click away and reversible, so an analyst can contain risk without waiting for a network change. Integrate EDR with your ticketing and chat so artifacts, process trees, hashes, and quarantine decisions land where responders work. With EDR in place, prevention errors turn into quick detections, and detections turn into bounded incidents rather than sprawling mysteries. Telemetry is only useful when it flows cleanly to investigations. Capture blocked events, rule hits, anomaly scores, and isolation actions with enough structure to filter by host, user, rule, and time. Normalize timestamps to trusted time sources. Enrich with asset and owner data, and forward to your analysis platform with durable queues so you do not lose the very signal you need during an incident. Keep dashboards boring and honest. Top blocks by rule, top new binaries seen, systems with stale agents, and endpoints with rising deny rates that may need help. The test is pragmatic. Can an on-call see why a host was contained, what fired, and what changed in less than 5 minutes without logging into the host? Validation protects you from false confidence. Run benign test artifacts that exercise your allowlisting, script controls, and firewall rules. Confirm that blocks occur with the messages and artifacts your playbooks expect. Schedule periodic adversary emulations, small, controlled runs of common techniques such as registry run keys, suspicious script execution, or credential reading attempts, and verify that HIPS or EDR fires while HIDS records the footprint. Capture packet and event trails for one golden case per technique and store them with your procedures so new analysts can study what right looks like. The goal is not to prove perfection, it is to find the seams in daylight and stitch them before a real adversary does. Every program fights familiar pitfalls, so address them with routines rather than reprimands. Broad antivirus and EDR exclusions added temporarily tend to persist. Schedule a weekly review that removes or narrows 3 at a time with owner sign-off. Unmanaged local administrator accounts creep back into images. Audit and replace them with just-in-time elevation tied to identity. Stale agents and sensors silently fail. Monitor version skew and last seen times, then fix with auto-remediation that retries and reports, not just alarms. Each fix leaves behind a small improvement note and a measurable change. Fewer blind spots, fewer silent bypasses, and a smaller difference between the hosts you think you have and the hosts you run. A concrete scenario shows the layers working together against ransomware before encryption begins. A user opens a booby-trapped document that spawns a script interpreter, which immediately tries to drop a loader and enumerate files. HIPS blocks the suspicious memory pattern and script child process, logging the call stack and parent path. Simultaneously, application allowlisting denies the unsigned binary, and the host firewall prevents an outbound handshake to the attacker's controller. EDR correlates the events into a high-confidence alert, captures the process tree, and automatically isolates the host from sensitive subnets while leaving a support channel open. HIDS notes that no protected files changed and no run keys were written. Within minutes, the analyst reviews artifacts, confirms no encryption began, rotates the user's tokens, and returns the host to service after a quick health check. 1 attempt, 3 controls, 0 crisis. We conclude with a short, practical sequence to turn intent into sturdier endpoints this month. First, run a baseline gap scan across one representative fleet segment and produce a one-page diff of services, ports, and policy items that diverge from your standard. Fix the top handful that reduce exposure the most. Second, remove 3 risky global exceptions: 1 broad antivirus exclusion, 1 firewall any egress rule on a sensitive role, and 1 allowlisting wildcard, and replace them with narrow, owned entries that expire. Third, execute a validation test. Fire a safe script block, a benign unsigned binary block, and a contained outbound attempt. Then capture the artifacts your playbook requires: event IDs, rule names, timestamps, and the isolation record. When those 3 moves are complete, you will have fewer surprises, clearer evidence, and hosts that resist, reveal, and recover in the face of real pressure. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.